Hi there. Today we're going to look at how to graph inequalities on ClassPad.net. So I have my blank screen here. We're going to be graphing inequalities. I'm going to click on the screen and get my options, and I want the graph. So I'm going to choose graph. I'm going to move it over here where I can look at it better. And down here at the bottom, I can either enter the inequality as a table if I wanted to enter it with data, or plot some points, but we're going to use the graphing where we actually just put in the inequality. So I'm going to just make up a simple one. So y, and to get the less than or equal to, you'll notice right here on the soft keyboard that pops up, here is my less than and greater than. If I want less than or equal to or greater than or equal to, they're down here. So let's start with just less than, just so you can see the difference. So let's just say x minus 1. And so what happens is you will see the line of x minus 1 where it would equal it. But notice, because this is an inequality and I don't have that equal sign, the line is automatically dotted. And if you click on it, you can actually see it. And what I like about this is when you click on it, you get your key points and you can see them at their key positions, right? So these are the key points. This is the point where I were. But what you'll notice is these are open circles, because since this is on the line of y is less than, they're not actually equal to that. If I were to change it, so let's actually graph a second inequality here. So how about we do y is greater than or equal to, I don't know, let's make it complicated, x squared. Oh, you know what? Let's make it negative, and it goes down. There we go. So what I want to show you is, and you know what, maybe I'm going to get rid of that point, is if I click on this, again, notice I get key points, and this one right here is a solid point because this graph has the equal sign in it, so it would be equal at that point. And then notice the intersection points are open because they're lying on that that y is less than line, so they're open there. They're not, if you're on the blue, it shows both of them. So graphing inequalities is very easy. You simply enter it as you would any function. You can also do things like, let's say I want to graph the region where x, and I just want to look at x. I could say where x is between, let's say -3 and is less than or equal to x, which is less than or equal to 4. I could also graph this region as well. So you can graph regions, and I want to show you the difference here. Notice, again, that where we have the equal sign, so x is greater than -3, that's a solid line. And if I click on it, its intersections are going to be solid. If I click over here, these are not solid. They're open because they're not equal to, because I have less than. So that's a really nice feature. It shows, you know, the open circles for when they're not actually equal to those values, the intersections, all those things. So now notice what's happening. Each inequality is getting its own color, and they're intersecting each other, right? And if I don't want to see them all at once, I can, let's hide this current one for a while, get that off so we can look at each function separately. Or I could pull them apart. But how do students know when a point is a solution to an inequality or not? So I could simply have them be looking here. I could plot a point. So let's plot a point. Let's just get that point. And I see that point up here. And notice now I can move this point, and now here is a point that's in the blue region, therefore it is a possible solution. Here is a point outside of that blue region, and it is not a possibility because it's not in the designated solution zone area colored in sections. So that's really nice too. You can quickly move points around to show solutions. I'm going to put this graph back just so I can show you the difference of let's show that graph again. So these are two inequalities that have intersected each other, right? And maybe I'm interested in points that are solutions to both of them. So how do I know which ones are solutions to both of them? Well, you can go by the color. So red, anything that's just red is only a solution to the red inequality, right? Anything that is blue is only a solution to the blue inequality, but anything that is a combination is purple. So that's one way, is to kind of think about overlapping colors. But I could also go up into my settings of my graph. So I'm in my graph sticky, I'm going to go to settings, and you'll notice down here there's this inequality plot. And right now it's automatically defaulting to show the union. So it's going to show all of the possible solutions together. But what if I only want to see where a solution is a solution to both of them at the same time? So when we look, if I choose intersection and I go back to my graph, you'll notice only those points that will satisfy both of these equations are here. And so this point, if it's here, it's not satisfying either of them, or well, it might be satisfying one, but only in this purple region am I actually satisfying both inequalities, right? And I could do the same thing. If I turn on this third inner graph, which we had turned off, because I'm still in my intersection position, it's only going to show the intersection of all three of those. So again, this is the feasible region for all three of them. This is important when you're dealing with, say, linear program type problems. So graphing inequalities is very much just enter the inequality. It will shade in. It will put a dotted line if it's not equal to, and you'll have open circles when those solutions are not actual solutions, but they lie on the line or the function. You can limit these just as well. And you know what? I'm gonna pull out the blue graph just so we can look at that one separately here. And what I mean by that is if I want to limit this, so this is the inequality, but let's say I only want to look at values that are where x is greater than 0. I only want to look at those solutions, right? So watch what happens is now my solution, I have limited my domain, and therefore my inequality solutions are also limited as well. So very much like you would do a normal function, except you're going to be using the less than, the inequality symbols, less than, greater than or equal to, less than or equal to.